To find the equation of a sine or cosine function from a given graph, you need to find the amplitude, period, and phase shift. So, given the graph of one complete period, find the sine or cosine equation. And we're going to use either this equation for sine or this equation for cosine, one or the other. So let's look at the first graph here. We see for here that it starts off at 0, goes up to 4, goes down to -4, and ends at 2 pi. Easiest thing to find is the amplitude. It goes as high as 4 and as low as -4. So we could say that the amplitude is equal to 4. As for the period, well, we know it goes from 0 to 2 pi, so the period is 2 pi, but we need to know what k is. So period is equal to 2 pi. And the way we get the period is to do 2 pi over k. So this is what the period is, and this is what we use to get the period. So the only difference here is that the period is 2 pi over 1, which makes k equal to 1. And the graph has not been shifted because normally a sine function starts at 0 and ends on the x-axis. Cosine would start up here or down here depending on whether it's reflected or not. So since it's starting at the origin, I can comfortably say that this is a sine function. And since it's starting at 0, I can tell that there is no phase shift. So y equals a sine k x minus b is the form. Now I just plug in everything I know. So y equals 4 sine k is just 1, so I don't really need the k. And b is 0 because there's no phase shift. So I can just say that this is y equals 4 sine x. And that is the function for this sine wave. Next we have this trig wave starting up here at 1.5, going down to -1.5, then coming back up to 1.5. And since it's not starting at the origin, I'm going to go with this as a cosine function. And since it goes as high as 1.5 and as low as -1.5, I'm going to say that the amplitude is equal to 1.5, or 3 over 2 if you prefer to use a fraction, whichever you want. Period again, from 0 to 2 pi over 3, so it's a period of 2 pi over 3. And we get the period by doing 2 pi over k. So what does k have to be to get 2 pi over 3? K would have to be 3. And again, this is starting up here on the y-axis, so I'm going to assume that there is no phase shift. So starting up here, going down and going back up again, I feel confident no phase shift, and still sticking with a cosine function. So y equals a cosine of k x minus b. Now let's plug in what I know. Y equals 3 over 2, or 1.5, whichever you prefer. I'm going to use a fraction. Cosine of 3, and I don't have a b since it's a 0, so I'm going to make this parentheses instead. So 3x. So there's my equation of this cosine wave. Last, I have this wave, a little bit odd, not starting at a nice high point or a low point, and it's not starting at the origin, so it's a little bit odd. But I can see that it's not starting in the middle like sine does. It's starting at a lowest point. So I feel fairly certain that it's a cosine, but since it's starting down here, it means it's probably a reflected cosine wave. So I'm going to have a negative in front of my entire function, and I see that this goes down as low as negative 0.5, and I will assume that this goes up to positive 0.5 as well. So that means its amplitude is 0.5, or you could even say a half. Both are acceptable. Period is a little bit different. It's starting at negative pi over 3 and ending at 2 pi over 3. So to get the period, what we're going to do is we're going to find out how far it is here, the distance. So distance is going to be 2 pi over 3 minus negative pi over 3, which is just going to be plus. So 2 pi over 3 plus pi over 3, which will give us 3 pi over 3, which is just pi. So that's my period. And I know that the period can be found by doing 2 pi over k. So it's a little bit different because now I have 2 pi over k equals pi. It's not like the others. It's not as simple and as easy just by looking at it. But we can do just a little bit of algebra to get it. I'm just going to get k by itself, so I'm going to multiply k over and then divide pi over. And when I do that, I'm going to get 2 pi over pi equals k. And this is nice and easy. 2 pi over pi is just going to give me 2. So k in this case is 2. And like I said, this doesn't start on the y-axis at a high or a low point. It's kind of starting somewhere in the middle. So I can see that normally it would start here for a cosine graph, but it's been moved over to the left pi over 3. So I can say that my b value, this time I actually have one, is from the left pi over 3. So now I got my amplitude, got my period, which gave me my k, and I got my phase shift. But don't forget, there was a reflection. A reflection about the x-axis. So we need to count that in as well. So let's get everything on one screen. And since I said this is a cosine function, I'll use the form for cosine. A cosine kx minus b. And plug in everything I know. So y equals a reflection about the x-axis makes my a value negative. So a negative 1/2 or 0.5, whichever you prefer. Cosine of k, which is 2, x. And since it's going to the left pi over 3, so I'll emphasize this to the left, this is going to be minus a negative pi over 3. One more parentheses, a short one. And now just we'll kind of work out the double negatives. Y equals negative 1/2 cosine of 2 times x plus pi over 3. And that is my equation for this cosine wave.